Welcome back. So the question here is, what is the largest average velocity of blood flow in an artery of radius 2 into 10 to the power minus 3 meter if the flow must remain laminar? The diameter of the artery is D, which is equal to 2R. As the radius is given here, so we need to do this. So 2 into 10 to the power minus 3, which is 4 into 10 to the power minus 3. The viscosity of blood is 2.08 into 10 to the power minus 3 Pascal second. The density of blood is rho, which is equal to 1.06 into 10 to the power 3 kg per meter cube. The average velocity is given by V average equals N RE eta divided by rho d. Taking the maximum value of Reynolds number, N RE equals 2000, at which laminar flow takes place, we have this 0.98 meter per second. So what is the corresponding flow rate? Take viscosity of blood to be 2.084 into 10 to the power minus 3 Pascal second. The volumetric flow rate is given as dV by dt, which is equal to V average pi r square. Now if we put in these values, we get this to be equal to 1.235 into 10 to the power minus 5 meter cube per second.